Hello and welcome to another video, this time on rates of change questions. So rates of change problems, and there's a few, and I've got a couple of a quadratic kind of modelling problem and a proof question at the end. And this was sent to me by May, so thanks for the questions, May. We'll see how we get on with these. They're all slightly different, I'm afraid, so it's hard to find the commonality between the questions, but actually there are some things in common that the first few have. Now, I probably should have started on one of the other rates of change questions rather than this one. I don't know, actually, I haven't worked through it, but let's just have a go. It looks like rates of change because it's describing, using a language, a rate of change. Yeah, look out for constant rate or anything like that, and then you know it's about differentiation. Now let's try and do this. We've got a large spherical balloon deflating, so that suggests the volume with respect to time is negative, i.e. dv by dt is definitely going to be negative here. And at time t seconds, the balloon has radius r and volume v. The volume of the balloon is modelled as decreasing at a constant rate. So dv by dt must equal minus k, yeah? Because the volume is changing with respect to time, so that's dv by dt, and it's doing it at a constant rate, so that's k, and it's decreasing, so that's minus k, yeah? And now we want to come up with dr by dt from dv by dt. Now these are chain rule problems. What you've got to do is you've got to know the volume of a sphere, yeah, because it's a large spherical balloon, so v equals 4/3 pi r cubed, yeah? And you're going to have to differentiate that and find dv by dr. Yeah, the 3 will come down and make it a 4 pi r squared. It differentiates to the surface area of a sphere, which is interesting, and there's very good reasons for that. But anyway, not to worry about that. Let's not get distracted. So at this point, it's a chain rule problem, yeah, because we know that dv by dt equals dv by dr multiplied by dr by dt. We've got dv by dt, it's minus k. Oh, and I might call this minus k because it annoys me when they do this, because my k might not be the same as their k. So I'm going to call it k hat, yeah, just to distinguish it from their k. And as long as their constant is my constant divided by or times by a number, then it's still a constant. And so what I'm going to do is I'm going to put minus k hat in here, and then dv by dr, well, I've got that, that's 4 pi r squared. And I'm multiplying that by dr by dt. Okay, at this point I can find what dr by dt equals. I can say dr by dt equals minus k hat divided by all of this. Now, you may not recognise it instantly, but we have actually finished the question here. We have. We just need a little remark to say, and this is of the form, it's of their form basically, because we've got a constant, dr by dt, a constant, over an r squared, yeah? And that's because if we just let my k hat over 4 pi equal k, then it's the same thing. My k hat over 4 pi is the same as their k, yeah? And then you get exactly the same answer as theirs. And so, yeah, that's how you do that one. Okay, and then for the next bit, and this is more typical, and can I point out, even if you don't get this answer in the exam, they've given you the answer, so you can still do part B. If it's a show that question, you can still do part B, yeah? Well worth remembering that. Too often students ignore the fact that they can get some marks later on in the question. Okay, the initial radius of the balloon is 40, so r equals 40 when t equals 0. After 5 seconds, the radius of the balloon is 20, so t equals 5, r equals 20. And the volume of the balloon continues to decrease at a constant rate until it's empty. Okay, solve the differential equation. So what are we going to be doing to solve this? Well, this is a classic example of separation of variables. It almost always is. So we're going to separate the variables. We're going to put the r squared with the dr and the dt on the other side. So I'm going to have r squared dr equals minus k dt, and I'm going to integrate both sides. Yeah, when I integrate the r squared, I get r cubed over 3. When I integrate minus k with respect to t, I get minus kt plus c. And now I'm going to work out k and c by plugging in my coordinates, essentially. So I get 40 cubed, which is 64000 over 3 equals c. And so I've now got r cubed over 3 equals minus kt plus 64,000 over 3. And then finally, plug in r equals 20 and t equals 5. So that's 8,000 over 3 equals minus 5k plus 64,000 over 3. Now, I haven't got a calculator, but at this point, it's just, obviously combine these two terms. You're going to have 8,000 minus 64,000, which is minus 56,000 over 3 equals minus 5k. And then you're just going to divide it by minus 5. So what is that going to give you? 5600 doubled, so 11,1200 over 3, I think, but check my arithmetic there. I haven't got a calculator nearby, but that's basically the rest of the question. The limitation on the values of t for which it's valid, well, bearing in mind it's completely empty after a certain thing, find when v equals 0 here, or when r equals 0 indeed, and yeah, when t is, find a t value for which that's the case, and then when t is larger than that, it's going to be invalid because it's going to give you a negative volume. Okay, this one's similar. Let's have a look at this one. The initial area of the circular stain is 0.09 centimeters squared. So that's an area, and as it's initial, it's saying a equals 0.09 when t equals 0. Then after 10 seconds, the area of the circular stain is 0.36. I think you need to give me part A here, the original differential equation. Solve the differential equation, yeah. I'll take a guess at what it is in a second, but it depends actually, how it's changing. It really does. I wonder, let me just have a look at I can probably take a guess at what it was if I can just see the original question. 1 second, I'm just hunting it down on my other monitor. Where is it? Here it is. Okay. Oh, yeah. All right. dA by dt is k over root a. I think you had in part A. So dA by dt is k over root a. Yeah. Was that something you had to show? Oh, is this part B from another question? Oh, yeah, sorry. So I see it now. I think this was the first part down here, and then that's part B. Yeah. So let's do this part first. Okay. So the rate of increase of its radius is inversely proportional to the square of its radius. Okay. So we're going to say the rate of increase of its radius, that's dr by dt. Yeah. Rate is always d something by dt. Yeah, so the rate of increase of radius is inversely proportional. That's 1 over, or k over, yeah, the square of the radius. So that's r squared, yeah. And at time t seconds, the circular stain has radius r and area a. And we've got to show that dA by dt is k over root a. Well, once again, I'm going to give it a k hat, yeah, because I don't know if my k is the same as their k, and that's the problem. So I call it k hat. And then I'm going to try and find dA by dt from this. So this is going to be a chain rule kind of problem. I'm going to say dA by dt. Well, that's going to be dA by dr multiplied by dr by dt. Now, the reason why I'm using that is because I've got dr by dt here, and I can find dA by dr because area for a circle is pi r squared. And so dA by dr is 2 pi r. And so what we can now do is say, okay, dA by dt is going to be 2 pi r times by k hat over r squared. Now that's going to give me 2 pi k hat over r. You might think, oh, well, they've got an a involved, but that's okay because we can bring a into it using a is pi r squared. And so r is going to be a over pi square rooted. Let's put it like this, 2 pi k hat times by a over pi square rooted. Yeah, and now I have got it in their form essentially. Let me just check that I've got everything right there because that looks slightly upside down to me. Oh, yeah, this shouldn't be a times, that should be a divided by. I was going to say, it looks wrong now. Okay, right, and now it's just a case of fiddling around with the algebra, and if we wrote this all as a square root of 4 pi squared k hat squared, we can write it like this over the square root of a pi. Then we can write it in one single square root, and we can do the 4 pi squared k hat squared, and we can simplify that with the a over pi, because basically it's going to become times by pi over a. And so what do we end up with? We end up with a square root over 4 pi cubed. K hat squared over A. Yeah. Now that is the same as their answer, because you're going to get 2 pi to the 3 over 2 K hat on the top and a root A on the bottom, and you can just say let their K equal 2 pi 3 over 2 K hat. Yeah, and the answers are the same. It's not an easy one, that one, but we've shown it's of their form, you know, and then just say hence the result is established. Flag to the examiner that you've finished your proof by explaining your reasoning. Yeah, always a good idea in maths. Okay, so that's that bit. And then this bit, we're just going to plug in the initial conditions and solve the differential equation. So A equals 0.36, T equals 10. Okay, we've already turned it into this much more convenient form. This is separate the variables. So put the root A with the dA. So A to the half dA equals K dt. Integrate both sides. You're going to have increased power by 1, divide by the new power, equals kt plus c. And now we'll plug in t equals 0, a equals 0.09. 0.09 is 9 over 100. Square root that, you're going to get 3/10. Cube it, you're going to get 27 over 1,000. 2/3 of 27 over 1,000 is 18 over 1,000. Oh, which can be simplified further, but let's just leave it like that. So 2a to the 2/3, sorry, 3 over 2. Equals kt plus 18 over 1,000. And then I'm just going to plug in 0.36, that's 36 over 100, also easy to square root, which is nice. So 36 over 100, square root, it is going to be 6 over 10, cubed is 216 over 1,000. 2/3 of 216 is 144, I think. So 144 over 1,000 is going to be equal to 10k plus 18 over 1,000. Let me know if I've got this wrong. I frequently do. What is that? 128, 126. Yeah, 124. Yeah, 126 over 1,000 is going to be equal to 10k, and so k equals 126 over 100, or 1.26. And there we go. We've got our complete equation. Linking A and T, what's that? Yeah, do they want it into A in terms of T? Sometimes they do. I've lost a question. Find a no, just an equation linking A and T, so we don't even have to tidy it up. Where was my answer? Do write down the final answer though. So 2a to the 3 over 2 over 3 equals 1.26 t plus 0.018. Yeah. And I think that should be right. Cool. Let me have a look at their answer. I just wanted to check it because I don't think you did send me the answers. Oh yeah, they've actually turned it all nice. Yeah, they did get 9 over 500, which is the same as my 18 over 1,000. Did they get 1.26 for K? I can't actually see. They did. They got 63 over 5,000, which I think is the same. But they did write theirs in a nice format in terms of A in terms of T. But that's not what the question asked. They just said, it just asked for an equation linking A and T, and so I'll leave mine like that. Okay, have I done all of these now? Okay, yeah, the last one I wanted to talk about, these ones. These ones bother me a little bit because they're basically saying, well, they don't bother me, like, let me tell you the difference. I'm going to do this a long way, but you don't have to do this a long way, yeah? They've said a radioactive particle N decays over time. The rate of decay of the particle is proportional to the number of particles remaining, yeah? Now, we could set up a differential equation for this and solve it to find the original equation, yeah? But they're saying write down, and write down in maths means you can just write down the answer. So if you're aware that any relationship where the rate of decay or increase, where the rate of increase or decrease is proportional to the size of the population or the value of x, that's always an exponential relationship every single time. So you are just allowed to write down here that n equals a e to the kt. You're absolutely allowed to just write that down. Yeah, and that is essentially the final answer. But I'm going to show you how I get this using differential equations. Here goes. The rate of decay, so dm by dt, is proportional to the number of particles remaining. Yeah, so that is proportional to n, so it equals kn. And what's more, if you want k to be positive, it will be equal to minus kn, because the rate of decrease basically is proportional to it's decaying. Basically, this is radioactive decay, and so the mass is getting smaller and smaller and smaller. Now with this, we can actually take the 1 over n onto this side and take the dt onto that side, separate the variables and integrate. Then we would integrate this to ln n, and this will become minus kt plus c. Yeah. Now I'm going to show you that that is the same as n equals ae to the kt. And I'm going to do that by, I'm going to exponentiate both sides. And then I'm going to write this as e to the c times by e to the minus kt. And then I'm going to let a equal e to the c, and I can see it's of exactly that format of a e to the minus kt. Yeah, so you could have written down this answer without proof, but you can also derive it as well very quickly if you actually separate the variables and rewrite it so it's in an exponential relationship. And you're allowed to do that when it says just write down. So if it ever asks you to model a situation where the rate of change is proportional to the current population, the classic thing where I use this for is population modelling, yeah, because the rate of change of population is almost always one nice way of modelling any population is to say it's equal to, it's proportional to the number of people in the population. In other words, more people in the population, well, the population's going to be growing faster. Fewer people in the population's not going to be growing as fast. And it's always an exponential situation because population tends to grow exponentially. Okay, so that was that one. Now, I liked your proof here. I think it would be given full marks, actually. I would prefer to do it, I think they did it in the mark scheme like this as well. As soon as I looked at it, I thought, consider odds, consider evens, yeah? Just because it seemed quicker, yeah? Because what your method here is basically saying is every number is of the form 4m, 4m plus 1, 4m plus 2, or 4m plus 3. Yeah, every single number is either a multiple of 4, 1 more than a multiple of 4, 2 more than a multiple of 4, or 3 more than a multiple of 4. And then you've shown that in each one of those cases, after squaring it and adding 2, the result is not divisible by 4. Now the result is definitely not divisible by 4 here or here, and that's just because when you square an odd number, you get an odd number, and then you're adding 2 to it, so you're still odd, yeah, and no multiples of 4 are odd, and that's why when you've got odd numbers it definitely doesn't work. And can I point out as well, that's what they're trying to tell you in the mark scheme for this one. And I thought it was interesting reading the mark scheme actually, and I agree it's harder for students to understand what the mark scheme's trying to tell us. But I'm just going to quickly just take a picture of the mark scheme, 1 second, because I just want to show you what they're trying to say here. It's really interesting. But I like your method though, and I think it would be given full marks. What they're saying here is like, don't just try numbers, that never gets you anything, yeah? True enough. You can mix and match methods though, so you could say, oh, when n is odd, the square of an odd is odd, and adding 2 you're still odd, and that's definitely not even, yeah? So you don't have to use an algebraic approach here. You may see odd numbers via logic and even via algebra. I just used logic basically to show odd squared is odd, plus 2 you're still on odd, and so therefore the answer can't be divisible by 4. But you can mix and match your methods. They're even using modular arithmetic down here. Very impressed with that. That's a classy way of doing it, but you don't have to worry about that. But yeah, and don't worry about things like proof via induction. That's something else as well. You could do it in an inductive proof as well here. But I like your way of doing it, but I probably would have done it like this. I probably would have just said consider. It's called polarity actually when you consider odd and even cases. Consider polarity. Let m be odd, i.e. let n equal 2m plus 1, where m is a member of the natural numbers, yeah? Or let's have integers. Yeah, okay, then what we're going to get, 2m plus 1 squared plus 2. I would have done it very similar to you here. That's 4m squared plus 4m plus 1 plus 2, so that's 4m squared plus 4m plus 3. Yeah, this is clearly not a multiple of 4, as it's 3 more than a multiple of 4. Might be even more obvious if you write it like this. This is clearly 3 more than a multiple of 4. And then I just say let n be even, i.e., and this is very similar to your one, let n equal 2m, and I just have 2m all squared plus 2, and that's going to give me 4m squared plus 2, and this is 2 more than a multiple of 4. And hence not a multiple of 4. Hence, as all numbers are either odd or even, as all numbers are either odd or even, it follows that it can't be a multiple of 4. As all numbers are a multiple of 4. Don't worry about the spider, sweetie. Sorry, my little girl quite likes my spider robot that I've built her. But anyway, as all numbers are either odd or even, it follows no number. It follows all numbers. Well, let's just say the result follows. The result follows. They should understand that. Okay, last one I wanted to talk to you about was the quadratic inequality, yeah? These are just like, do you remember the GCSE questions? Where you had to like draw several lines and label the region R, yeah? This is just like this. It's not an integration question, it's actually a regions question. Except one of the lines is quadratic. That's all there is to it, yeah? Now, the difficult bit is definitely going to be finding the quadratic line. So let's should we do the easier bit first? Yeah, let's do the easier bit first. Let's find the equation of L. Equation of L. Okay, right. The equation of L, I've got 2 points it goes through, so I can work out the gradient there, dead easy. Okay, we've got m equals, right, change in y, 4, divided by change in x, 4, but it's going to be negative because you can see it's got a negative gradient, so that's y equals minus 1. So m equals minus 1. And then I'm going to write it down like that, plug in a number, 2, 4 will do. 4 equals minus 2 plus c, and so c is 6, and so that equation must be y equals minus x add 6, yeah? Now we want to be on this side of the line, not that side of the line. This is y equals minus x add 6. On all points on this side of the line, y is actually bigger than minus x plus 6, and on all points on this side of the line, y is actually smaller than minus x add 6. Now how do I know which side is which? Well, it's dead easy to do actually. You just take a point and test it. The classic point to test would be 0, 0, yeah? Is 0 less than negative 0 add 6? Yes it is. 0 is less than 6. And so this side of the line is where y is less than minus x add 6. And you can check, take a point over here like 6, 6, which will be on that side of the line, and here you'll find that 6 is bigger than minus 6 plus 6, and so that's the correct side for that line. So when we're doing this region, we need y is less than minus x add 6 for this side of the line, yeah? Now let's do the quadratic. The quadratic is harder to do, yeah? We're basically trying to model a quadratic with 3 points. We've got 2, 4, 0, 0, and 6, 0. Probably the easiest way of doing this is to think, well, it goes through 0, 0, and 6, 0. So you know it's definitely of the form x times x minus 6. And you might think that's the end of it. But there's no guarantee that that's the right answer, because 2, 4 might not lie in this line. So what you actually have to do is write y equals a x minus 6. I hope you can see why I'm using x and x minus 6 there. It's because that's where the roots are. This just basically stretches it, the a, so that it goes through 2, 4. And so I'm going to put in 4 equals a times 2 times by 2 minus 6. Okay, what am I going to get here? I'm going to get 4 equals 2 minus 6 is minus 4. Minus 4 times 2 is minus 8. So a times minus 8 is 4. A is going to have to be minus half there. And therefore, our equation must be minus a half x times by x minus 6, yeah? There's various ways of working it out though, but I prefer that way because it's even quicker than the line in some ways. You know, you've got the roots, so you've got the factorised form, and then you can just stretch it so it's going through that point. Now, I wonder, this is, let's get rid of the other scribbles I've got in there, but I'm just going to make a note that this is where y is less than minus x add 6, yeah? Now, okay, big question for me now is, this is the quadratic y equals minus a half x minus 6. Now, I wonder, is underneath y less than minus a half x minus 6? Let's test a point. This point, 3, 0, is quite clearly underneath the curve. Okay, is 0 less than minus a half times 3 times by 3 minus 6? Well, it takes a little bit of working out because you're going to get minus 1.5 there times by minus 3 there. And minus 1.5 times by minus 3 is like is positive 4.5, yeah? And positive 4.5 is bigger than 0, yes? I'm just testing a point here. And so this is indeed where that's true, whereas above here, all around here, we will have y is greater than minus a half x minus 6, and that includes in the region R, yeah? It's on this side of the quadratic where y will be bigger than minus a half x minus 6. So to divide, use inequalities to define R, and I'm going to do this in set notation as well. I'm going to say this region, R is the region. Right, let's do it in set notation. X such that, or we're doing it with y's and x's here, aren't we? Let's just do that. Yeah, using inequalities to define the region R. I would like to use a little bit of Boolean algebra. Y is less than, what was it? Y is less than, I wrote it down, minus x add 6. And, yeah, you need that little and symbol. Y is greater than minus a half x minus 6. And that is the final answer. I'm just going to check it. Bibsy, give me the glass. Give me the glass, Bibsy. Oh, she's gone. Don't drop that glass. Okay, right. Did I get it right? I'm just looking on the other screen now. Let's have a look. Y is greater than or equal to. Okay, yeah. So they're using or equal to's. It depends if... It does depend. Let's have a look at the question, see if it's really clearly defined. Doesn't say whether the line's included or excluded. They should allow either basically here, but now do I need anything else? I've got y is less than that. Oh yeah, I do need x is greater than 0 though. I did miss that. And x is greater than 0. The reason why I need and x is greater than 0, at the moment my region just goes out here, yeah, but I need x is greater than 0 to make sure my region is just that triangle left over, yeah, just so it's bounded like that. But it's very similar to regions in GCSE, just with quadratics involved as well. So yeah, there you go. Hope that makes sense and hope that's useful. Keep up the hard work and all the best. Bye bye.